Okay, Algebra 1, 8.5a. We're looking at intercept form, learning target eigengraph quadratic using intercept form. So what we're going to do, we're going to kind of work through what it is, finding the axis of symmetry, and then getting a graph down. Tomorrow we'll go over some extras, domain and range, and then, yeah, that's pretty much it. So here we go. What intercept form looks like is it gives us the x-intercepts. It is basically factored form is what it is. It looks like f of x equals a, and then we've got x minus p times x minus q. And this is factored form for a quadratic. There's the a value, x minus p, x minus q. Some notable things. X-intercepts are p and q. And remember, this is just like anytime we're looking at like vertex form. If I see x minus p, if I saw x minus 5, that means that that intercept is 5. So we kind of are looking at opposite signs here again. The axis of symmetry, AOS, axis of symmetry, is between p comma 0, that's one of the intercepts, and q comma 0, that's the other intercept. Meaning x is equal to p plus q divided by 2. And we'll get a little graphic of what that looks like. Okay, the a value, this is again stretches, shrinks, and if it's negative, x-axis reflection. Stretch, shrink, reflect. Okay, quick, just like, hey, this is what it looks like in intercept form. Let's make some graph paper. And we can have the vertex wherever we want. Let's go ahead and go here, here, and here. So here's my quadratic. And this is some quadratic. I don't know what it is exactly. I guess let's get rid of the paper. That way we don't have any exact values. This point would be p comma 0. This point would be q comma 0. This is our axis of symmetry. It's going to be x equals p plus q divided by 2. And those are really the only three things that we have out of intercept form. Whether it opens up or down based on the a value, the two intercepts, and we can find the axis of symmetry. Finding the vertex is difficult in this form. We don't have that x equals negative b over 2a because we don't have this in standard form. What we could do, though, is once we know what the axis of symmetry is, we can plug that value into the equation and solve for the y value, and that will tell us where the vertex is. And let's go ahead and look at an example. And we can find all of those things. F of x equals, I don't want to use that one. Let's go with want one with an a value here. It's not going to give me one with an a value, I don't think. Okay, there we go. This is number 10 from the book, and it is an h of x. And this is the only example we're going to do because we're splitting this into a couple days. This is h of x equals -4. We've got x minus 7, x minus 3. And let's go ahead and get some information down. The things that we can find the vertex. We can find the axis of symmetry. We can find the zeros, which would be, we're going to go ahead and take those out to the x-intercepts. Remember, zeros are just the y-coordinate. The x-intercept is the x and y coordinate. Wow, I am doing magnificent today. So let's find these three things, and then that'll be it. That's what we want to be able to do today. So the first thing we're going to find, the two easiest ones are the axis of symmetry and the zeros. And we can sketch this out. Let's sketch it out too. So we're going to use paper for this part. Okay, the AOS, the axis of symmetry. Let's start with zeros. Zeros will be easiest because they'll lead into what the axis of symmetry is. Okay, the zeros. This is in factored form. If you're having a hard time recognizing that it is the opposite of what we see, this is P, this is Q, and what we need to look at is it's the opposite sign of what we see. If we have a hard time remembering, remember this is x minus 7 equals 0 and x minus 3 equals 0. This is the zero product property. That means that x equals 7 and x equals 3. Those are my two zeros. My x-intercepts coming off of that are at 7, 0 and 3, 0. Now my axis of symmetry is these two numbers added together and divided by 2. X equals 7 plus 3 divided by 2. That is 10 divided by 2, that is 5. So x equals 5 is my axis of symmetry. And the last thing we were going to do, we got vertex. Vertex is at 5, I don't know what it is, but I'm going to plug 5 into the function and find out. Remember, the vertex is on the axis of symmetry. So the x-coordinate is the same as the axis of symmetry. All right, x equals 5. Let's plug it into the function. H of 5 equals -4, 5 minus 7, 5 minus 3. -4 times -2 times 2. That is 8 times 2, that is 16. 5, 16. We're probably going to drop the graph paper from this because I'm not going to do 16 squares. And then the last thing we're going to do is sketch this. And again, we're dropping graph paper because I'm not going to do 16 squares and take up a bunch of this. All right, the pieces that we have. We've got a graph, a vertex somewhere at 5, 16. It's going to be something like this. And actually, let's move that off to the side. And then we've got two intercepts at 3 and 7. So this is going to be 3, 0, 7 comma 0. And we've got our axis of symmetry. I'll go ahead and make it red. That is x equals 5. So these are all the pieces that we have, and we can sketch it. We know it opens down because the a value is negative. It has a reflection in the x-axis. Something like that. That 1 going through 7 is kind of closing in, but it is a sketch. So there's our sketch. There's the information that we get. This is most of what you're going to see on a problem. On question 10, it does ask for domain and range. We'll do those tomorrow, and we'll call this good for now. That is it for today.